All right, kiddos, today we're going to talk about expected value. It is good to have a calculator handy for this lesson. It does not have to be a graphing calculator though. So we're just going to learn the vocabulary for expected value and calculate expected value of a discrete random variable and determine if an event is fair. Okay, so let's just look at. All right, so today's lesson we're going to go over expected value, and our goal is just to learn the vocabulary for expected value and calculate expected value of a discrete random variable and determine if an event is fair. So it is handy to have a calculator available, so if you have one, it does not have to be a graphing calculator for this lesson. So just taking this first example, it says in your wallet you have 10 $1 bills, 4 $5 bills, and 1 $20 bill. You're going to reach into the wallet and remove a bill without looking. What is the expected value of the bill you will take out? So first of all, let's just go over what expected value is. Expected value is when you're taking the probability of an event happening and combining it with what you would receive. In this case, it's money, sometimes it's points, things like that, what you would receive in return. So I'm going to take the probability of each event happening. Okay, so if I got a $1 bill, okay, there's 10 of those, and the probability of that happening, if there's a total of, looks like there's 15 different bills, so the probability of that happening is 10 out of 15, or 2/3. And that, what I get in return is $1. Okay. Then 4 $5 bills. So there's 4 $5 bills out of a total of 15 bills. And if you get one of those, you get $5. And then lastly, one $20 bill. So 1 out of 15 chance that I'm going to get a 20. So now all expected value is doing is it's combining these things. So I'm going to take the probability of getting a 1 times what we would receive, which is 1. I'm going to take the probability of drawing a $5 bill times what we would receive, which is 5. And then the last one as well. So in a moment, this is what I'm going to put into my calculator. So I get a value of 6. What that means is you're expected to get a value of $6. Now we all know when you reach into this wallet, there's no such thing as a $6 bill. You can't actually come out with a $6 bill. But what expected value does is it's taking the average over time. So if you were to play this game or reach in your wallet and do this trick several times over and over and over and over again, you would expect to receive on average each turn $6. Okay. Again, we know we can't just draw a $6 bill out, but hopefully that kind of makes sense. All right, so this next one uses a spinner, and you spin the spinner and you will win or lose, because there's a negative value on there, the amount labeled in each section. So in this one, when I'm thinking about the probability of different events, okay, I see that they're all split up into fourths, right? Each of those situations have a 1/4 chance of happening. And what would I receive in each of those? Well, there's one where you'd receive 20, 0, 5, and -10. It's important to keep that negative on there. So when I'm calculating the expected value, I'm going to say 1/4 times 20 for this first one. And then I can do 1/4 times 0, but I know that that's going to be 0, so I'm just not going to worry about even putting that in my calculator. And then I'm going to do that for the rest. Okay, so I'm going to put this into my calculator right now. All right, so I get $3.75. It's okay to have some change. It's okay that it's not a number that is actually on the spinner. It's just saying if you were to play this game where you spin the spinner over and over and over again, what you would end up getting is you would gain $3.75 on average. Now I want you to take this into consideration, okay? We've been getting all positive numbers for our expected value. What would it mean if I got a negative number? So let's just say, what if instead of getting $3.75 that's positive, let's say my answer was this. It doesn't mean my answer is wrong. You can have a negative expected value. What this means is that you would be losing $3.75 on average. So you can get positives and negative numbers for expected value. Okay, this is just an example though. So expected value is an event is the sum of the probability of each possible outcome of the experiment multiplied by the outcome's value. And we kind of talked about this a little bit, but this is more a definition that you would see in a math textbook, so you'd recognize what it is. This basically means that you're taking the sum of. So in this situation, it says the following probability model describes the number of credits taken by a randomly selected first-year student at a large state university. Now, the average, you may know, is most kids take about 15 credits, okay? Maybe one more credit or one less credit. Taking 17 credits in a semester in college is not very common, is what I'm trying to say. So I like this example because it's not talking about money. You know, it gives us something else to deal with. We're talking about credits instead. So what I'm going to do is I'm just going to take each situation and say 14 is what we would get. Probably that happening is 0.05. And then the probability of them taking 15 credits is 65%. And so I'm just setting up the same situation that we've been doing. All right, so I'm going to put that in my calculator. If you had to make a guess, what would you think that it would be near your answer? Do you think it's going to be closest to something like 17? Probably not, because it's not very likely of happening. We see that the likelihood is right here, right? Like 65% is the highest percent that we have on there. So we know it's going to be around 15 credits, right? We could expect to have first-year college students at a large state university taking around 15 credits. So we end up with an answer after I put this in my calculator, 15.35 credits. Now we know kids can't actually take 15.35 credits, but if a college is trying to look at what to expect their first-year students to do, on average, about 15.35 credits for each first-year student is what they can kind of count on. All right, so we're back to a deck of cards, and 4 cards within the deck of 52 cards are aces. You're offered the following wager. You're going to draw 1 card at random from the deck. You win $15 if the card drawn is an ace. Otherwise, you lose $1. And if you make this wager many times, what will be the mean outcome? Okay, so we want to know, like, is this a fair game? And you're going to play this a lot. Does that benefit you or not? So I'm going to set up this. I'm going to say, what's the probability? I'll keep these over here. I should maybe have that on the right. But so there's 2 outcomes. You will either win $15 or you're going to lose $1. And the way I'm going to put it is -1 because you're losing $1. The only way you gain $15 is if you get an ace. And it tells us that there's 4 aces in the deck. But this has to be a probability in this column, remember. So I'm going to divide by something. And in this case, I'm going to divide by 52. So in every other situation, any other card other than an ace that you draw, you will lose $1. So we have to think how many cards in the deck are not aces. Well, there's 48 of them. And so that's how I get that other probability. And now I'm just going to set it up as the probability times what you would receive. And then I'm going to put it all on my calculator. And think to yourself, what do you think it's going to be? Do you think it's going to be a positive expected value or a negative expected value? We get positive, 0.231. All right, so on average, you're going to win 23 cents every time you play this. To me, those odds aren't even though it's positive and you should end up getting more money, it's just not a very fun game to play. You're not going to gain that much very fast, probably. So anyways. All right, here's another one. So a deck of 52 cards contains 13 hearts. Here's another wager. You're going to draw 1 card at random from the deck. If the card's a heart, you win $5. So I'm just going to write this down right away. If the card's a heart, you win $5, and there's 13 hearts in the deck. Otherwise, you lose $1. Okay, so let's see here. We still lose $1, except now instead of having 48 out of 52, we're going to have 39 out of 52 chances to lose $1. So setting it up with the probability times the outcome. All right, so I'm just going to put that in my calculator. Do you think this is going to be a better offer than the last one? So this one you don't win as much, but you have more probability to win. So that's kind of why it's different than last example we just did. This ends up with an expected value of 50 cents. So if you were to pick a game, which game would you want to play? Well, I hope you would say this one, the one on the orange slide, because you're gaining 50 cents on average versus 23 cents. It's a much better game for you to play. All right, so this one says that we're going to play a game, and there's two possible outcomes, outcome A and outcome B. Outcome A has a probability of 0.4, and outcome B is probably 0.6. When B occurs, you win $2, otherwise you lose $1. Okay, what's your expected value for this game? So again, we're going to set up, and I'm going to put that in my calculator. I get negative 0.48. So our expected value is that we're going to lose 48 cents on average every time that we play this game. So if your friend asks you to play this game, would you want to play it? I would hope you'd say no. All right, so in these two, it looks like two neighboring states have similar lotteries. Each lottery costs $1 to enter. Okay, so this is where we're going to start introducing what do we do if there's a fee to pay, or you have to pay to play. Okay, so what I want us to do is we're going to first of all calculate state A's expected value. So I'm going to multiply these two things and add it to these two things multiplied, and so on and so forth. I just don't have enough room to write it, so I'm just multiplying those in my calculator right now. So I get 0.7 here, and then I'm going to do the same thing for the state B's lottery. Okay, so I'm going to find the expected value by multiplying these and then adding it to those multiplied, and so on and so forth. All right, so this one ends up being 0.725. So I guess I could have done my work down here. So this is this, and this is that. Given a choice, which state's lottery would you play and why? I'm hoping you'd say you'd play state B's lottery, because they have a higher expected value, even though it's just such a small amount. But, oh, I totally forgot something. Hold on, back up, Mrs. Wiitala. I forgot about that $1 to pay to play, okay? I didn't include that anywhere, so we need to back up and include that. So when you find your expected value, what you can do is you can subtract the amount it takes to pay to play. So when I look here now I'm down to negative 0.3, okay? You're losing 30 cents on average. And then for this one, you're losing 0.275, okay? You're losing less. So really, actually, this question down below, given a choice, which lottery would you play? I would probably say neither, because you're going to lose money on average, but some people play the lottery anyways, and so if you had to choose, you'd choose state B because you're going to lose less money. And what do you think when you're actually playing the lottery? Do you think it's going to have a positive or a negative expected value for you? Well, it's going to have a negative expected value for you, and that's how the state makes money off of it, right? There's a purpose to that. All right, so now we're going to get into warranty type problems. So you buy a camera for $300 and you're considering buying a replacement plan. So when you go into a place like Best Buy, they're going to offer you, if you're buying some sort of electronic, they'll offer you a protection plan or something like that, that you can buy that offers you a little more protection while you have the product if something goes wrong or something like that. Now, a lot of devices will have a manufacturer's warranty, so it's important to know what the manufacturer already offers you when you're doing this, but we're just going to look at what happens with these plans. So you buy a camera, Best Buy offers you, hey, $75 for a replacement plan. And what that means is if the camera breaks in the next 2 years, you'll get your $300 back. And the probability that the camera will break is 2%. So what's the expected value of the replacement plan for the customer? So let's just set it up like this, like we have been doing. There's 2 different outcomes, right? So if your camera breaks, okay, you get the $300 minus $75. All right, so I can't remember where I left off here. I had to help a kid. So I just want to make sure I reiterate. There's 2 different outcomes. You can get $300 back, but just remember they don't give you the money back for the replacement plan. So you're out $75. That's why I'm subtracting $75 from here. So, all right, so then the other outcome is you could just lose $75. You're out $75. And you might ask why. If you buy the replacement plan and your camera doesn't break, they don't give you that $75 back. You didn't use the replacement plan, but you had it there in case you needed it, okay? So the probability that the camera breaks and that you get $300 and then minus the $75 that you paid for the plan is 2%, okay? So that means that the probability that the camera doesn't break is 98%. So when I set this up, I'm putting in 225 because I subtracted 75 away from 300. And this is going to help me calculate the expected value. So I get negative 69, which means on average, every person that they get to sign up for this warranty plan is going to lose $69. Who's gaining the $69? The company that offers the replacement plan is expected to receive on average $69 for every person that they get to sign up for this plan. Is this fair? Okay, is this event fair? An event is considered to be fair if the expected value is 0, so it means it breaks even. It must be fair to all parties, not just the consumer or you. So it says a national sweepstakes awards one prize of $1 million, 10 prizes of $100,000, and 1,000 prizes of $1,000. If 10 million people enter the sweepstakes, what's a fair amount to pay for a ticket? Okay, so when we look at this, there's one prize out of, what did they say, 10 million? 10 million people enter the, okay. And if you win that, you get 1 million. Okay. There's 10 prizes of 100,000. Sorry, I need to put 10 million in the bottom here. It's going a little too fast. That's if you win 100,000. And 1,000 prizes. You win $1,000. Okay, so I'm going to pause this and I'm going to actually calculate this while you wait. After calculating this, we get 30 cents. So every time you play this, you expect to get 30 cents. But it's out of 10 million. That's just kind of crazy. So it says, what's a fair amount to pay for a ticket? Well, we have to think, what could we subtract from here so that we get an expected value of 0? And so the fair value to offer for the ticket would be that somebody had to pay 30 cents, okay, to get that to even out. All right, so you spin the spinner below and you win or lose the amount labeled. Now what they're doing is they're changing this. This is the same problem that we did. If you pay $5 to play the game, is it fair? Okay, so we're going to say 20 times 1/4, just because I don't know what the value was before. Negative 10 times 1/4 plus 0 times 1/4, which doesn't really matter. That'll be 0 plus 5 times 1/4. So I'm just going to calculate the expected value really quick again. So So I get the expected value was 6.228. Is that right? Hold on, let me just double check. No, that's not right. Hold on. Okay, I get 3.75. That sounds more right. So in order to make the expected value or this game fair, or no, we're not trying to make it fair. We're trying to pay $5. So I'm going to subtract $5 from there, and we get negative $1.25. Is this game fair if you're paying $5 to play? No, it is not. You're going to lose on average $1.25 every time that you play it. Now, what rate should somebody have paid to make it fair? Should have been $3.75 to even it out. Okay. So it looks like your homework is an expected value worksheet. If you have any questions, reach out to your teacher.